So we have talked about the last couple of days, we've been talking about the half angles applying to triangles and the double angles applying to triangles. And I want to take a little bit deeper look at double angles. And we're going to use them eventually in the trig formulas in the verification. So once again, we may want to take out our pink papers and look at these just to help us, because what I did for sine of 2 theta is I wrote it as a sum. Theta plus theta. 1 theta plus 1 theta is 2 theta. And if we can break it out like that, then we know what the sum identity is. It's going to be the very first one listed on our pink paper. And then that means that it's going to be sine of theta times cosine of theta. Because there's a plus in here, we're going to have a plus. And then it's going to be cosine of theta, which, by the way, it's the first theta. Here's the A, and there's B. So it's sine of A, which is the first theta. Cosine of B, it's the second theta. And then when we switch it over here, cosine of the first value, there's the A, and sine of the second. Now, it doesn't make any difference, but just to point that out, because we haven't been using this identity for a little while. So sine of theta cosine theta plus cosine of theta sine of theta. By the way, you don't even have to write this next step, but sine of theta cosine of theta, we can turn this around and write it as sine of theta cosine of theta. If you don't recognize that those are like terms. And when we add like terms, we add the coefficients. There's a 1 in front of this sine theta cosine theta. There's a 1 in front of that sine cosine theta. And what we end up with is 1 plus 1 is 2. Sine theta cosine of theta. And if you look down in your double angle identities, our first identity is that sine of 2 theta. And sure enough, sine of 2 theta equals 2 sine theta cosine theta. Again, you don't need to memorize these. They will be provided for you. That's where it came from. And we can look at that alternatively when we look at the cosine here on this second value. Cosine of 2 theta. If we write it with the sum and difference here, and we fill it in, we get cosine of theta times cosine of theta. Since we're adding these two together, as we look down at our pink paper, we see that we're going to be subtracting. And then it's going to be sine of theta and sine of theta. And we can simplify. Cosine times cosine. Well, we did cosine times itself, which is cosine squared. And sine times sine. Sine times itself is sine squared. And as we look back again at our pink paper, kind of right in the very middle of the pink paper, it talks about the fact that the cosine of 2 theta does equal cosine squared minus sine squared. One more, the tangent. And tangent of theta plus theta. Well, as we look at our paper here, well, we took the tangent of 2 theta, and we wrote 2 theta as 1 theta plus 1 theta. So now we can apply our sum identity, and that's going to say that we're going to fill in tangent of theta plus tangent of theta divided by 1 minus. Again, watch out for the signs in these identities, because since it's tangent plus, the plus is on the top of the identity. So we're going to use the sign on top, which is plus here, but in the denominator, the sign that's on top is the minus, and it's going to be tangent theta times tangent theta. And once again, because they're both thetas, it makes this somewhat nice. But we have to recognize that those are like terms. 1 plus 1 is 2 tangent theta. And then down here in the denominator, 1 minus tangent times tangent is tangent squared. And as we compare it on our pink paper, we get tangent of 2 theta equals that value. So now that we see where the double angles come from, let's come down here and let's do some verifying of our identities here. And remember, when we verify an identity, we only work on one side. And we really want to start with the more complicated side. And oftentimes, the more complicated side is the left side, as it is in this first problem. And in this particular problem, it's the cosine of pi minus x. So this is going to be a sum and difference identity if you're looking back at your pink paper. So we're going to fill that in. And I, again, want to just remind you that this is A and this is B when we're filling them in. The pi is the A and the x is the B. So we fill it in. It's going to become cosine of pi times cosine of x. In this case, this one is subtracting. So here we're going to add. And then as we complete the rest of the identity, this is going to be sine of pi times sine of x. Well, now that we fill that in, what does the cosine of pi equal? And once again, let me remind you, this. So this point here to the far right is 1, 0, 0, 1, negative 1, 0, 0, negative 1. What's the cosine of pi? It's going to be negative 1. And we're going to still multiply that by cosine of x. Well, can we figure out what the sine of pi equals? Well, the sine is going to be the y value in our order pairs. That's going to be 0 times sine of x. Well, it's nice because it's 0. Because what happens is 0 times sine of x is 0. And we get negative 1 cosine of x, which is really negative cosine of x. And on our other side here, we get negative cosine of x. So we have to go back and remember our values on the unit circle to be able to verify these. But at least on this particular one, it was a lot shorter than what we've been dealing with before. Let's look at problem number 2 here. And again, we're going to be verifying, so we're only going to work on one side. And we've got sine squared x plus cosine of 2x. And the first thing that I think, at least on this particular problem, is what does cosine of 2x equal? Let's fill that in. So it's sine squared x plus, well, we looked on our pink paper, and what it says is it says that it's cosine squared x minus sine squared x. And again, what we're trying to do is we're trying to turn the left side of this equation into the right side. But the cosine 2x we were able to fill in, and now when we go back and look at this, sine squared x, negative sine squared x, they're like terms. One's positive, one's negative. They cancel out. And what we end up with is we end up with cosine squared x equals cosine squared x. Again, if we have these identities in front of us, it may be helpful for us. And certainly with the sine identities and cosine identities, they are a little less complex than tangent. So what happens when we turn over our notes? Tangent. But in this particular case, again, I am going to start with the left side. And we're going to fill in our identity of it's the tangent of theta tangent of pi over 4 minus theta, which is going to be a sum and difference identity. So when we go back and fill this one in, this is going to be tangent of pi over 4 minus a tangent of theta. That's our top value. Again, we have to watch out for the signs since it's minus. Back here on our pink paper, the minus is on the bottom sign. So it's going to be minus here in the numerator, but then it's going to be 1 plus tangent of pi over 4 times tangent of theta. Well, the hardest part about this problem here is, do you know / remember what the tangent of pi over 4 is? And it's 1. So if we know that, then this is very straightforward. Tangent of pi over 4 is 1 minus tangent of theta. Down here in the denominator, this is 1 plus tangent of pi over 4 is 1 times tangent of theta. And 1 times tangent of theta is just tangent of theta. So we really end up with 1 minus tangent of theta in the numerator, 1 plus tangent of theta in the denominator. And when we compare back to our other side, sure enough, we have 1 minus tangent of theta divided by 1 plus tangent of theta. Oh well, but I'll be... last one. Sine squared of theta over 2. So here's a half angle problem. And we haven't even looked at any half angles today, but here it comes. Going to still stick with the left side. And as we look back to our pink paper, what the half angle says for sine of theta over 2, our identity is plus or minus, and then it's going to be 1 minus cosine theta divided by 2. But luckily, it doesn't say the sine of theta divided by 2. It says sine squared of theta over 2. We have to square that. And the thing is, for some of you, you're thinking, well, what am I going to do with that plus or minus? Well, when we square something that's positive, we're going to be dealing with positive times positive, and what does positive times positive equal? Positive. Well, if we square negative, that means a negative value times a negative value, and what does negative times negative equal? It still equals positive. So don't get caught up here in the signs, because positive squared is positive, negative squared is positive. And then lastly, what we have is we've got the square root squared. Those are inverse operations. So what we have to do now is we can get rid of the square root. Again, square rooting and squaring cancel each other out. But our next step, it's the dicey step. And I admit, I had to step back and think. I did not know what to do. I had to go back to my trig verifications problem, and I had to look at my steps, some suggestions. But what ended up happening here is, at some point, I need to turn my left side of the equation into secant. And what we're going to do is we're going to multiply by secant of theta over secant of theta. We're going to multiply by a fancy form of 1. is what I ended up doing. There may be some other way, but that's what I came up with here. I needed to start getting secant back into the equation. We're still working on the left side to turn it into the right side. But remember, when we have fractions here, we multiply the tops together and we multiply the bottoms together, and we don't necessarily need all of those parentheses in there. But I do want to show all of my work. And what happens is we end up with secant of theta minus cosine theta secant theta. We distributed that secant. Down here in the denominator, we get 2 times secant of theta. And that's how I knew I was on the right track, because look at the other side. The other side in the denominator is 2 secant of theta. So we came up with that. So we're closer now. We need to deal with the numerator. But what do we know about the relationship between secant and cosine? They're reciprocals. So this is secant of theta minus cosine of theta times 1 over cosine of theta. Still divided by the 2 secant of theta. And remember, when we multiply the tops, we multiply the bottoms. We don't have to find a common denominator to multiply. So now we have secant theta minus cosine of theta divided by cosine of theta, all divided by 2 secant of theta. So what does cosine of theta divided by cosine of theta equal? 1. And we end up now secant of theta minus 1 divided by 2 secant of theta. And when we compare it back to our other side, we've got secant of theta minus 1 divided by 2 secant of theta. Secant of theta minus 1 divided by 2 secant of theta. Remember, only use one side when you're verifying.